So if you've ever wondered how free-moving ions or mobile electrons conduct electricity, what I'm going to do is I'm going to draw a couple of pictures, and hopefully this gives you a lot more clarity when to use the word ions and electrons when answering chemical bonding questions. Hi everyone, it's Jeremy from the classroom, and let's get started. Okay, so here what I've done is I've already drawn two setups, or rather two diagrams. On the left, you see your aqueous sodium chloride, all right, and in aqueous sodium chloride, you basically will have sodium ions and chloride ions. And it's the presence of these free-moving ions that will allow electricity to be conducted. So plus, minus, plus, minus, plus, minus. Now, on the other hand, all right, if you look at the metal bar, we know that there are electrons that are delocalized, that are mobile, that allows electricity to be conducted. Now, but what does this actually mean? So what I'm going to do is I'm going to try and combine them and give you a much clearer idea. So this is a light bulb. For those of you not too sure, light bulb. And then here we have your silver metal. All right, and of course here you have your sodium chloride aqueous. Now, first question, will the light bulb light up? Answer is no. Why? Because there is no energy source. We need a battery in order for it to light up. Okay, now the second thing you need to understand here is this, that let's once again look here. All right, now you need to understand that in the silver metal and in the copper wire, there are already electrons. So the electrons are actually already there. I'm just going to draw two electrons, okay, because I have no space. All right, so imagine there are only two electrons. More there. Okay, so there are electrons there. The electrons are already found in the wire and in the metal. They're just basically there waiting to be pushed in a particular direction. The electrons do not come from the battery. All right, so that's a misconception number one. Electrons do not come from the battery. They're already found in the wire. Now, when you place a battery there, all a battery is going to do, all right, minus plus, is that it's going to provide an energy to start pushing. So I'm going to highlight in yellow now. The first electron is going to get pushed into the position of the second one. Second gets pushed into third. Third gets pushed into fourth. Now, where does the fourth electron go to? The fourth electron here will get pushed into a cation. So if I were to expand the diagram, all right, let's call this silver A, all right, silver A, yeah, all right, if this is A, if I were to expand, okay, the electron will basically be pushed into whatever cation is in contact with the electrode, or with the metal bar. Okay, so whatever cation is in contact with the silver metal bar, will gain one electron. All right, but this makes the electrolyte, the sodium chloride, no longer electrically neutral. So if electrons are being gained somewhere else electrons must be lost. And that is what's happening here at the other side. Let's call this B. All right, so silver B. Okay, so at silver B, the anion that's closest to it will lose an electron. All right, okay, so the electron will be pushed into silver B. All right, and let me just once again draw you a bigger picture so you know what's happening. So because the electrolyte is no longer neutral, this anion will lose an electron, push its way up, and then the one in yellow here will then be pushed upwards, and this will be pushed forward, and so on and so forth. So what we see there is how electrons are now flowing in the metal bar and in the wire, and in the electrolyte, we basically have your cations and your anions basically gaining and losing electrons to facilitate the whole flow of electrons. All right, so that's how electricity is being conducted, and therefore for electrolytes, for your aqueous electrolytes, it is the presence of free-moving ions. Notice there are no electrons in the electrolyte, only free-moving ions, and in your metal bar, there are only your mobile delocalized electrons. Let me just highlight in yellow, yeah, okay? And so this is how the flow of electrons in a circuit works. I hope this gives you a much clearer idea on when to use electrons and ions. See you next time.